I am recording.
There it is.
There we are.
Okay. And I'd like to welcome you, the audience, who's here to meet with me and hear what I'm talking about. And let me get my PowerPoint slides set up and share the screen. And let me see if I can get this. Okay, here we are. Share. There's my PowerPoint. I will be with you in 1 second. Let me get the slideshow from the beginning. Okay, well, welcome tonight. Okay, I'm Dr. Jay Lucker, and as it says on the PowerPoint slide, I am a professor emeritus from Howard University in Washington, D.C., and I'm also an invited adjunct professor at North Carolina Central University in Durham, North Carolina. Okay, this review that we're going to go through today, okay, is a discussion of research methods for speech language pathologists, where questions on the praxis exam may ask you questions about research. So we're going to go through a discussion of research methods, and periodically what I will do is submit to you a question about research. Let's see how much you've gained from what we've talked about. So let us get started. As it says here, there are different types of research, and the first general category for speech language pathologists to think about is called clinical research. And essentially, I think you probably, when you're in graduate school especially, you probably read a lot of things, and I'm sure that a lot of the things that you're reading, for your classes and all, have to do with research studies. You may even have to read some of the journals, the ASHA journals, as well as others. And basically, clinical research is just straightforward to the name. It is research that basically advances our knowledge of how specific things that we use as speech language pathologists work in clinical applications. Okay, example, evaluation tools, evaluations, methods of evaluations, okay, therapy and methods of therapy that we use, and also the material that we might use. And these are clinically oriented things, okay? They provide evidence of the validity of a clinic application of something. So I'll give you an example. If a question came up on the praxis exam that says, John Smith just published a study. The study talks about a new evaluation tool. And John Smith talks about how this evaluation tool should be submitted or presented to clients, the age levels used, and also the questions that are asked on that tool. You got that? Those things would all be clinically oriented. Now, here is another question for you, and I'll pause to make you think about it. If you would like to, I would be more than happy to have you turn your microphone on and even answer it if you would like. That's up to you. Okay? Okay, we'll make believe I'll use Jane Doe, okay, published something on new research that Jane Doe completed. She used a brand new evaluation of, let's say, articulation, okay, and she talks about the articulation evaluation having to do this new test having to do with evaluating vowels and evaluating different kinds of phonemes and using rhyming words and using sentences and maybe even pictures where you have to describe things, but you have to listen to, as the therapist, what the person is doing. Okay. Would that be clinical research? If you'd like to try to answer, I'm happy to have you answer. You can turn your microphone on. Okay, answer it in your head. There's a piece of it that's not clinical. Describing the test itself is not clinical, right? Describing where she got the pictures from, that's not necessarily clinical. But how you administer it would be clinical, and how you may score it would be clinical. So there's the difference between clinical research and some other types of research. Okay? In essence, we should always follow clinical research studies that are published because they provide evidence-based practice. If I was to say I published a new test, it's really the best test in the world, and I really want everyone to use it. Here's the name of the test. Here's here's where you can purchase it and all. Would you agree that has nothing to do with clinical research? As a matter of fact, the thing I left out was anything to support the validity of what this new test is, and even the reliability, meaning is it appropriate even, right? The appropriateness of it. So it would not be clinical research. It wouldn't be, may not be research at all, just descriptive stuff. Okay. So there's something called translational research, another general area. Okay, questions may come up about that. Example is research on a face-to-face basis versus what we do, as we call it, teletherapy or distance, right? Okay, so we're looking at that research and we're going to translate that research and its findings into our practice. Maybe you've been thinking about, do I really have to go to the office all the time? Can I just do evaluations, speech evaluations, voice evaluations, okay, even swallowing evaluations or language evaluations virtually? Can I do that? Well, let's say I find some research that studied this and looked at how well face-to-face, in-person evaluations work, what therapy works versus virtual. Okay. The thing is that is clinical research, but it could be translational research if what the person's doing is these are the things you need to do. This is how to do it. Because what they're doing is they're giving you the research to translate it into your work. Okay. Then there's implementation research, and you'll see that these three research things, they're kind of mixed, okay? But remember, clinical research focuses on clinic, okay? If I was to describe a disorder, and just describe the disorder, and then do some research on the disorder showing how it changes the brain, I hope you would agree that's very good research, but it's not clinically specific, right? Would you, as a speech language pathologist doing clinical work, use that information in your actual therapy, in your actual? No, maybe you'd think about it, right? Maybe you use it as a base to understand the disorder better, right? So it's not something that you would implement or use, okay? Implemental research is it's in implementing our services. This involves things again like in-person virtual teletherapy. It looks at clinician resources, your expertise. Here's a great example. Let's say someone posted research on people doing swallow therapy, and they have two groups. One group is a group of people who have had uh, dysphagia training and also CEUs increases. So they've been taking therapy lessons, they've been doing things on dysphagia for, let's say, 5 or 6 years. The second group, they just graduated from school, they had one course that covered swallow. and swallow therapy. So here comes it. Would that be good therapy? Would that be good research? Yeah, how could you implement it? Well, I just graduated. Am I really that good in this field? Well, from reading this research, what I just learned is I need to really keep up to date and really maybe study more. And I just found out that in my whatever you live in my city, in the town, the area where I live, there's going to be two new courses on dysphagia and swallow therapy. I think I better take them, even though I graduated and I took a course 2 years ago. Maybe I should stay up to date and keep learning some new stuff. I'm going to implement this to improve my clinician expertise, my clinical expertise, and also what resources do they discuss? Maybe there's some new things that I should use, and maybe I can learn more about them. Also, what implementation research might talk about is barriers. There's things that are, kind of prevent our ability to do the therapies or evaluations that we're providing. Okay, good example. You want to evaluate a person's language abilities in English, but the person only speaks another language. I think there's a barrier there. They don't understand English. Are you going to really be able to evaluate their English? It's easy. I just evaluated it. They only speak one language. They don't speak English. They're English language learners, or what we abbreviate as ELL. Is it a barrier to services? No. It's a barrier to do the traditional language therapy that I use with the other clients that I see who are primary English speakers and have been speaking English their whole lives. Okay? But the thing is, English language learners need ESL, what we used to call ESL, English as a second language training, as opposed to the language therapy we might use for a native or a person who speaks English as their primary language. Okay. The research process. So that's a little bit about some general concepts about, what we call it, about research. And questions come up. They could be very scientifically based. Maybe they're not clinically based. They're not clinical therapy or clinical research. Maybe there's clinical based research, but it talks about how you can use this to increase your abilities and grow as a clinician, right? Okay. Or maybe there's research that shows you how to implement these things in your actual work. So, what is the research process? This is where more questions, if anything, would show up. Okay. The first thing is research is scientific. And the scientific principles are the ability to do the tasks, whatever the research is, the tests, the therapy, okay, whatever task we're asking, is it testable? In other words, if someone's doing research, is the research that they're doing usable for us? And what they did was testable, meaning they use very good test methods, and I could use those methods too. If I'm doing a speech articulation research, and I notice that they've used something like the Goldman-Friston-Woodcock test of articulation, I think that's appropriate. It's very testable for articulation therapy. That was very appropriate. Now, let's say someone does therapy. It's a joke. Please take it as that. And they take people to the moon, have them take off their helmets, and they have to speak on the moon. They have to listen to me talking to them on the moon. I hope you would think that's not very testable. That's not very doable. That's not very valid. There's no air on the moon. And I hope you would agree, in order to hear something, there better be air, not for breathing, but air, because air is what causes sound, right? When we speak, it's air that's producing the sound, and the sound waves and air waves moving the sound in frequencies and rhythms, which we call sine waves, is the way I hear. Is it reliable? So what I'm going to do is ask you, is it reliable? Reliable, which means in research, reliability is, can it be replicated? Can you do it? Can you do it? I doubt very much if we're going to take a trip to the moon. I don't think we have the ability. Well, we could, but let's say just us who's here. I don't think we have the ability. So it's not reliable for us because we can't do that. Okay. Okay. An objective. Are the research questions? Does the person hear us when they take off their helmet on the moon? Well, maybe they're only going to be alive for as long as they can hold their breath. Okay. And the thing is, they have a research question. In the research process, typical research is done by taking a question and converting it to what's called the null hypothesis. What is the null hypothesis? Okay, you have two groups, you're comparing them. One group, we'll call group A, you're doing something brand new with them. Group B, that's the old way we do things. You're doing therapy. The same therapy with group A and group B. And there's something different about group A and B, or even better, you're going to use a new treatment therapy with group A and the standard old treatment therapy with group B. You're going to compare them. Okay? Is that testable? Yeah. As long as you know and have learned the new treatment therapy and you know the old treatment therapy, okay, what would the hypothesis be? Well, let's make believe that we're very concerned about this new therapy. We want it to show greater improvement than the old therapy so that people will start using this new therapy. Okay, so that's really what we want in our mind. The null hypothesis is there would be no difference in improvement whether you use the new therapy or the old therapy. What's our hope in doing the research is to disprove the null hypothesis, that there is an improvement. Okay? That's what we hope. Now, the next person comes in and they don't think there's really much difference between the new therapy and the old therapy. Their null hypothesis is there is no difference, but their desire is to prove the null hypothesis is true, that there is no difference. Stay with the old therapy or learn the new therapy. You're not going to find a difference in improvement. So it all depends on what the person is trying to prove. There are three different types of research, and we're going to go through all of them. One is called descriptive research, which describes things, its name. Exploratory research, which explores relationships. And experimental research. And we'll talk about all three of these, as it says. We'll come back to these. Research questions and a null hypothesis. I've already talked a little about that. Does the review of the existing literature answer our research question? In other words, when you do research, there's also previous research. Here's an example. Okay, I'm going to do a study on evaluating speech articulation using the Goldman-Fristow with, let's say, children who are in first grade through fifth grade elementary school, kindergarten through fifth grade elementary school. Okay, how many of you would agree that what am I doing that for? There's probably existing literature on this. First of all, look at the Goldman-Fristow as the test that was used in this therapy, and it already did research. And it will make believe children from kindergarten through fifth grade as well as others, okay? And will make believe that they used hundreds of children. Well, it's a good amount of children, a good size sample. And that's something that can come up also on the practice example. And we'll talk a little more about that soon. But if I'm doing research on 10 children, okay, would that be sufficient to make the research usable and the conclusions and findings valid? If anyone would like to turn their mic on, you can answer the question. Otherwise, I'll give the answer. I'll say it again. You're reading research, and it's on looking at articulation disorders, articulation in children from kindergarten through fifth grade. They use the Goldman-Bristow, the Goldman-Bristow test of articulation. And the most up-to-date one, I think, is third edition. And the thing is, they then talk about this and they want to know, is it valid with this age group? I hope you would agree with me, right? That basically what they're doing is replicable. There's already norms, right? Of course, it's valid. There's norms. So therefore, it's not a null hypothesis. The hypothesis would be, are the children performing the way the norms would say they are? We'll make believe that we have two groups, kids with known articulation disorders, kids with no articulation disorders. I hope you would agree that kids with no articulation disorders should pass with no disorders at all. They should be able to produce every single word with every single phoneme properly, and then using it in sentences properly. The kids with articulation disorders would fail. What we haven't talked about, what articulation disorder, just articulation disorder in general. Okay? So we could be saying that we're taking this and seeing if it is applicable to our use, which we know it is. If you use the Goldman-Bristow, it's a very commonly used test of articulation. Okay? What we may do is try to replicate the norms or replicate a research study that was already done and redo it. We could replicate it just to see is it truly valid? Well, if you found it, you, the researchers, found it with, let's say, 25 subjects, and we're going to now do it with 25 subjects, we should find the same kinds of improvements, same kinds of changes. You might find, I'm making this up, okay, an improvement on a level from 1 to 5 of 5. We did it also on an improvement of 1 to 5 and found 4.5. Would you agree? We're both around 5. And we found that improvements in both cases. Maybe there's something different in our subjects than your subjects. So our subject didn't do as well as your subjects. Maybe they had greater articulation problems than your subjects, but they all had articulation problems. It all depends. Okay. In terms of this null hypothesis, there is a difference. There is no difference. Okay. There's something called descriptive research. When you do research that just describes things, there typically is no null hypothesis. As a matter of fact, very often the hypothesis is very open-ended. Okay, we'll go into the different types of research, descriptive, exploratory, experimental, in a moment. But as the statement says, descriptive research does not have an hypothesis. But if you're exploring a relationship, there's your null hypothesis. There is no relationship, but you're trying to prove there is. If you're looking at an experiment, there is an improvement. There is this, or whatever you're looking at, this therapy is the best to use. Okay, this technique, this material was the most appropriate to use. The null hypothesis is there's no difference between this material and the other material or the standard material, or whatever else we're investigating. So null hypothesis and the null hypothesis. An hypothesis is an educated guess because you state the hypothesis based on your research question, like, does the speech language articulation, no, let's go through the therapy. Does the material used for this type of therapy, is it appropriate to show an improvement in, let's say, expressive language for describing things? Okay, so we're going to use pictures of something, and the research will describe the pictures. Would that be appropriate in terms of determining is there an improvement. Our null hypothesis is if we use these pictures versus just open-ended, no pictures at all, there would be no difference. Our expectation is the pictures makes it better, and therefore there should be a difference. Okay? And so therefore, the null hypothesis, there is no difference, is what we test out, typically to prove there is a difference, but sometimes to prove there is no difference, because we don't want to show, we'll make believe, we don't believe these pictures are better than these pictures. There wouldn't be a difference between them. Or even better, these pictures are better than a video. Okay? In-person therapy is better than virtual therapy. Those are things that people might have tested out. And the thing is, the hypothesis is we don't believe there's a difference, but we may want virtual therapy to be equal. There is no difference. Great. Or maybe we'll find virtual therapy is better. Depends on what we want. No hypothesis, there is no difference. In an experimental study, there is no difference. I made a mistake here. In an exploratory study, there is no relationship. In an experimental study, there is no difference. That's what there is no experimental, or there is no relationship exploratory, right? And we either support there is or refute it, depending on the outcomes of our research. Okay, steps. First thing we very often do is we do a review of the literature, and we come up with a question. And that question usually is, okay? So when we come up with a specific research question, then we decide, do we want to do this by manipulating things? That's called an experimental way. Or by looking to see if there's some relationship between. And we'll talk a little more about experimental and exploratory soon more. And again, no hypothesis, there is no difference, there is no relationship. What we might want to do is agree with that or disagree there is a difference to determine whether A or B, or if there's A, B, C, D, which one is the better for whatever we're testing out. We test out the null hypothesis using statistical analyses. And we'll discuss a little more about what statistics are used. Descriptive research describes things, and its research question is not a null hypothesis. Its research question is very open-ended. How much improvement do we get? Or better yet, with that, what do people notice about the improvement in their speech? Okay, what do clients think about virtual therapy? What does the teacher see in the student who has language therapy? Are they doing better in class or whatever? Would you agree those things are, this is me talking now, not Asha necessarily. It's very subjective. It looks at very subjective things. But what if we asked a lot of people? Here's an example, student in school, classroom teacher will ask the same questions to the teacher aide or assistant, okay? We'll ask a lot of questions also to, let's say, the phys ed teacher of that class, focusing on that child speaking, okay? We'll ask the parent. Let's see what each of them say about the child, the student, or the students, if it's more than one, before we start therapy. Then we'll do 2-3 months of therapy for their language, expressibility, receptive understanding, and all, and ask them to respond again, maybe to the same questions. I've done descriptive research and it's very open to the same questions. And let's make believe you start at this level with the questions from all of the participants, and all of a sudden it goes up to this level. You can't say there is an improvement. What you say is, from the data provided, the observations of these people show that they see an improvement. But I don't have data to say what the improvement is. right? It's very, very open-ended. Is there an improvement, or do people notice an improvement after 3 months of therapy in whatever the disorder is, whatever the problem is? Very open-ended, okay? And that's important because we want to know that sometimes. What do people think of virtual therapy versus in-person therapy? Because what we can learn from that is people love the virtual therapy because you don't have to take the time off. You don't have to rush out of, I'm thinking of students in school, rush out of taking the kid out of school and rush them to the therapy session and then do some, practice at home on top of all their homework, right? But now if we do in-person therapy, virtual therapy, they can come home, they can be doing the therapy while you're getting dinner set up, right? And then they can do their homework, right? Okay. Exploratory research looks to see if there's a relationship, and we call it a correlation. Is there a greater improvement if we see someone 5 days a week for therapy versus if we see people 1 day a week for therapy? That's an experiment. The correlation might be, what's the relationship between the amount of improvement when you have therapy 1 day a week, let's say for 2 months, or 5 days a week for 2 months? Is there a relationship? So there may be a relationship with the amount of time the person puts in. And we're not looking so much at, is there a difference? Although eventually that could wind up being the case. But a relationship. Example, is there a relationship between the amount of improvement and the number of hours of therapy? We could use the same clients. So what we do is we see the clients for one session, see how much improvement there is. We see them for 2 sessions, how much improvement there is. See them for 3 sessions, how much improvement there is. And then see, is there a relationship between 1 session, 2 sessions, 3 sessions, 4 sessions? What we probably observe descriptively is probably the more sessions, the more improvement you may see. But now we could test it out and see, is there a relationship between it? And in our hypothesis, there's no significant relationship. Okay. Experimental research. Research carefully controls all the variables. I've been talking about research. I haven't talked about the relation, the variables. Variables, what are they? Okay. What clients did you choose? Okay. If they had a language disorder, how was it evaluated? What's their degree of, where are they? What's their language? Let's make believe the language is receptive understanding of verbs. Notice it's more narrow than receptive language in general, right? Okay. Okay. So that I'm controlling that. And maybe I have two groups. I'm looking at group A and group B. Okay. They may be of different ages. They may be, once a week therapy versus everyday therapy. Okay. It all depends on what I'm testing out for an experiment. What I do is to see, is there a greater effect in the 5 days a week of therapy versus the 1 day a week of therapy, let's say for 3 months? And we'd have two groups, one group with only once a week, one group with 5 days a week. And the thing is, I've controlled that. Cause and effect. The number of days of therapy per week show a significant improvement. The 5 days a week, let's say, showed much better improvement than the 1 day a week. What would be a conclusion? It's probably best to see the person who has this XYZ disorder, to get this ABC therapy every day rather than just once a week. Okay, so we have variables. In this example that I show here, do more hours of therapy cause greater improvement? 100 hours does not cause more significant improvement than 25 hours. There's my two groups. I'm going to do 100 hours of therapy versus 25. Variables, the number of hours of therapy, right? What therapy was used, We could use the same exact therapy. We'd want the same exact disorder, the same exact degree of disorder, maybe the same age groups, okay? Maybe the same history, types of background case history stuff, so that what we're looking at is just certain things, because all these other things that I'm bringing up, case history, okay, ages of the people, okay, the actual therapies that are being used, okay, how the people respond to the therapy could be what? A factor that influences the improvement or lack of improvement. Okay, so we have now general categories of research. There are three. Now, this has to do with types of research, okay? And that is, there's something called quantitative research, and there's qualitative research, and then there's quantitative plus qualitative called mixed. These research categories have to do with when we do statistical analyses. Does everyone get that? So if you're doing descriptive research, just fill out this questionnaire or whatever, okay? There may be no statistics involved. I'm just describing things. And I may bring this up again, but let me just say for now that this type of descriptive research, typically what we're looking for is proof from multiple sources, usually what they call a triangulation. Three things. Make believe the teacher found that the therapy did show an improvement, or the child did show improvement in expressing him or herself in class after having the therapy. The parent showed the child showed an improvement in expressing him or herself. Okay? And then let's say we use what? The phys ed teacher showed an improvement when the child was asking questions or responding to questions asked of the child. Would you agree? Three people, independent of each other, have identified the child showed improvement. And what we were seeing is, what was the time period of improvement? The time period of therapy. We'll make believe it's, 6 months of therapy. And the improvement is from the first prior to therapy starting, and how these people see the improvement 6 months later. If we wanted to, though, that kind of research is descriptive. But if we did exploratory research, relationship, versus or experimental research, we use numbers. And the numbers we use are called the quantitative research. I'm going to give you 5 words, repeat them. Articulation. So we're doing 5 words, all starting with the same phoneme. Okay. How well did you do? Got 4 out of 5 correct. I use 5 because it's an easy, well, I'll use 10. 10 words. 4 out of 10 is 40%, right? There's numbers, real numbers, 40%, right? Okay. uh, we could also use 4 out of 5, just using the number 4 out of 5. Okay, but then the easiest, best way to do that is 4 divided by 5, which I think is 80%. Excuse me, 80%. And then we're getting a number, a numeric value. When you do evals, I think we all do what? We use what? Standard scores. We use scale scores. We may use percentiles. Those are real numbers. So that is quantitative research. And we use those numbers in our statistical analysis. Sometimes we don't use numbers, we just use words. Ready? Here we are. I'm going to give you those 5 words to repeat. You got only 2 out of 5 words. And I'm going to write down, you did poorly. Okay? You got 4 out of 5 words. You did good or very good. You got 5 out of 5 words. You did excellent. Okay? You did, let's say, 3 out of 5. You did fairly good. Notice I'm using verbal words. Okay? Poor, poorly. You did poorly. You did fairly good, right? You did good. You did excellent. Now, I want to do statistics. I can arbitrarily give a value to those. Now, before, when I did 4 out of 5, made it 80%, I gave it a real number. 4 out of 5 is a real number. But if you did good, excellent, poor, whatever, let's do it easier way to start with. Did you speak correctly or incorrectly? Did you produce those words with correct articulation or incorrect? Okay, correct articulation, we like that. We're going to give it a 1. Incorrect articulation, we're going to give it a 0. Did you do poor? We're going to give that a 1. Did you do good? We're going to give that a 2. Did you do excellent? We're going to give that a 3. Would you agree the numbers 1, 2, and 3 for how you performed are not real numbers? The 1 represents poor, the 2 represents good, and the 3 represents excellent or perfect. Pass or fail. We use 1 and a 0, or 0 and 1, depending on what we want to evaluate. We arbitrarily label numbers for the words. And therefore, we can do what's called qualitative research and use qualitative analyses. We'll talk about what those are in a moment. And of course, you could do research where you're measuring more than one thing. And one thing might be real numbers, quantitative research, and then one of the things could be just qualitative, where we're going to use numbers to describe, but we have to, in our research, describe what the words are and then what the numbers are. Okay. Quantitative research, real numbers. The numbers that we use are called parametric numbers. They're real numbers that go by an interval. Here's an example. Okay, the numbers I used at the bottom, 1, 2, 3, all have 1 point difference. 1 or 0.5, 1.5, 2, 2.5, 3, 3.5, etc. Those are real numbers. 80%, that's a real number. 20%, that's a real number. Good. And I'm going to make that the number 1. It's not a real number. And would you agree? If we let's start with good, better, best. How's that? Okay. Good, better, best. 1, 2, and 3. Would you agree? The 1 to the 2 are not intervals. I just arbitrarily gave a number. Would you agree instead of good, better, best, instead of using 1, 2, and 3, I could have used 1, 2, we'd go by 2, 2, 4, and 6. Or I could have used the numbers 5, 10, and 15. 15 is better than 5, not 3 times better. I just arbitrarily gave it the number 15. Kind of silly. We usually use 1, 0, or 1, 2, 3, or whatever it is. Okay. When we do ratios, if you've heard of a ratio, ratios are percents. They're real numbers. Okay. For example, number over 100 is a percent. And that's why that, the 0/0% really, it kind of represents 100. If you put a 1 and then a 0/0, it would be 100, 100%. Okay, so ratios are also real numbers, parametric values. When we use the yes, no, 1 and 0, and there's called non-parametric. And we do have statistics that uses non-parametric statistical analysis. So can't throw it away. It can be used. I've done a lot of research using both parametric as well as non-parametric values. Experimental research, true, carefully controlled. Okay, we randomly select our subjects. Okay, we then just arbitrarily choose who's going to be in the experimental group, who's going to be in the control group or the comparison group. The difference between experimental and controlled is experimental means we're trying something experimentally new or different for this group versus whatever you do with the control group. Control group usually is whatever the normal standard way of doing things are. Comparison group might be, here we are, same therapy, but seen once a week, seen 5 times a week. We're comparing the once a week versus 5 times a week, as opposed to the new therapy versus the old therapy. Pictures versus videos in describing things. Okay? And we'd compare the differences between them. Statistically, if there's a difference, the null hypothesis, goodbye, there is a difference. Okay? Our hope is our experimental group, which is what we want, or it could be, I don't want the experimental group. I want the control or comparison group to do equal or better, which means that whatever I'm experimenting doesn't really work. Better than whatever else we normally do. With human beings, we can't control all variables. So what we get is called quasi or quasi-experimental research. Okay? Example, we may not assign themes randomly. We may carefully pick what we're using, not by age or anything, but other factors. Okay? Here's the best example I could think of as a quasi-experimental factor. You have a group, two groups that you're experimenting with on a new therapy. Group one gets the new therapy, and we'll call that new, and group two gets the old therapy, we'll call it old. So it's new versus old. And our null hypothesis would be what? New versus old experimental. New is our experimental group. The old is the control or comparison group. What's the null hypothesis? Think about it. If you want to answer, turn your mic on.
That the new treatment doesn't work.
Yeah, and therefore there is a difference, right?
No.
There is a
There's
difference that the new treatment doesn't work. Does that mean they're equal, or does that mean that the old treatment was better?
the old treatment was better.
Which means that we compare them, right?
Hmm.
You got it. Okay, give yourself a pat on the back, Savannah. Great, great answer. Right. And therefore, the null hypothesis would be there is no difference, but the finding would be there is a significant difference. The thing is, we want the new treatment to be better, but it wasn't. Or the null hypothesis is what? Equal. There is no difference. The two groups were equal. But in what you said, we say that the experimental group did not do better than the control group. There was no difference. Okay? Very good example. Okay? Thus, we have quasi-experimental for a very good reason. Could it be that one of the things was language therapy? Could it be that the kids in the experimental group all have barely passable IQs? And I hope you would agree with me, language therapy also involves a lot of cognitive things. An IQ is a cognitive measure, very often verbal IQ, language cognitive. Okay, so we're going to make believe they have 85 IQ as an average. That's the borderline of cutoff. Whereas the treatment of the control group, which did equal to the experiment, or did better than the experiment. Imagine if they all included people like Albert Einstein. I hope you understand what I'm saying. People with like 140 IQs. Maybe the difference between the two groups wasn't the therapy, but that when you work with the kids with the 85 IQ, it could take you 5 or 6 sessions until they finally understood what you're teaching them in the first session. Whereas with the other group, they're so bright, whatever you're teaching them in the first half of the first session, they already learned the skill and they're ready to use it. So maybe it was the IQ that made the difference. With human beings, we can't control those things. Or sometimes we can, but sometimes we don't think about that. So when we work with humans, very often we can't control all the variables, quasi-experimental. Therapy, treatment, two treatment groups. Imagine if one of the two treatment groups, all of the kids, all of the people in one of the treatment, in the whichever group it is, A or B, right? Or experimental control comparison, we'll do the experimental group. Experimental group gets therapy, but they also do practice at home with their parents. So they're getting double therapy in a sense. Whereas in the control comparison group, they only get the therapy we do with them. They get nothing at home at all. Would you agree? The fact that the experimental group did so much better, was it really art therapy? Or was the fact that they also got practice at home? So instead of doing, let's say, 1 hour a week, they did 1 hour a week with us for therapy and 1 hour every day with their parent. The other group, 1 hour a week with us, period. So these are doing what? 6 hours of therapy a week versus 1 hour, but we only counted because we can't control for all the variables. They're called quasi-experimental. It's what we do with human beings. Now comes the parametric and the non-parametric and what's important, the way we test things out. If we're testing two factors, group A and group B, which one is there a significant difference? One group, but therapy A and B tried with the same group. There's two factors. We would do a two-factor test. I made it up. It's not necessarily the name of it, but it's called the t-test. It is parametric. We use real numbers. Then we can do the t-test. Now, let's say we're doing a group, we're doing some comparison or some analysis, and we're doing something, but we're using, good, bad, yes, no, pass, fail, and we're going to apply numbers to them. For that type of two group or two thing test that we're doing, okay, we would use a Mann-Whitney U-test because the numbers that we use are made up numbers. First, the numbers don't really count as numbers, they're just labels. So that's a good way to say yes equals 1, no equals 0. Pass equals 1, fail equals 0. Now let's say we're doing errors incorrect. Okay, errors are 1 because we're looking at how many errors there are. No error is 0. So sometimes it's not always the good gets the higher number and the bad gets the lower number. In that case, error, I think, is the bad versus no error is good. But we're looking at errors as a factor. Therefore, we want to count them because we'll have more numbers to count. We'd be doing Mann-Whitney U-tests. We could do it for two groups or two things. Okay? If we're using two groups, we call them independent samples t-test. If we're looking at one group for two factors, it's called dependent, just get rid of the N, dependent samples or paired samples t-test. Okay? If we're doing one group for multiple things, let's say we're evaluating A, B, C, and D in the group. Okay? We're looking at their articulation, we're looking at their expressive language, we're looking at their receptive language, and we're making some comparisons. Did the articulation change based on whatever we're using for the variable that we're controlling? Time factors, the therapy we did, the materials we used, whatever it was. Then we're using multiple t-tests, which are called ANOVA, ANOVA, AN, analysis of variables. If we're doing two groups as t-tests, but if we're doing three groups, we have to compare group 1. Well, I'll do it this way. How about group 1 with group 2, group 1 with group 3, and group 2 with group 3. That would be a lot of t-tests. So what we do is ANOVA for multiple groups. If we're using, again, the non-parametric numbers, for the ANOVA factor, there's something called the KW multiple groups or multiple factors analysis. It's called the Kruskal-Wallis test. So think about that and think about the kinds of questions they can ask. You have, multiple, you have 5 groups and you're doing, here's a good one, okay? You're having a group getting therapy once a week. You're having another group getting therapy twice a week. You got to have another group doing therapy 5 times a week, another group doing therapy every day. 5 times a week, 4 times a week and 5 times a week. Okay, we have groups 1, 2, 3, 4. Okay, once a week, twice a week, 4 times a week, and 5 times a week. And we're going to compare it to see, is there differences between the groups? Maybe the 4 times a week, 5 times a week doesn't matter. Maybe the once and the twice a week doesn't matter. Okay, maybe they all matter. Okay, so what we would do there is we do the, for real numbers, ANOVA for one factor for all the groups, okay, or the Kruskal-Wallis one factor for all the groups, okay, but we could have multiple factors for multiple groups. We call that a MANOVA. Put an M in front of an over. Okay. If we're doing relationships, is there a relationship between the number of hours of therapy and the amount of improvement? There's a good relationship thing. What we do there is called a correlation. For the statistics, for parametric correlations, it's called Pearson. That's how I teach my students to say, try to remember, for parametric, it's Pearson. There's the P. It's called a Pearson, or sometimes called Pearson product correlation. And what we get is called an R factor, the relationship. And what we're looking for is relationships that either do match the null hypothesis, that's what we're looking for, or they do not. The null hypothesis is not significant. If we're doing this as non-parametric numbers, they're Spearman, also called the Spearman rho. Rho is the letter R, and I think Greek, right? Rho is Greek for R, relationship. So we have correlation, Pearson for parametric, and Spearman rho for relationship, non-parametric. Okay. For ANOVA, you could do one group. I already talked about this, called the one-way analysis of a variable, or you can use many groups with many measures. Then it's called the multiple, because many groups and many measures MANOVA. For non-parametric differences, we could do the Kruskal-Wallis, the KW, or especially if we're doing just 2 things, although sometimes you can do 3 things, it's called chi-square. For those who aren't familiar with Greek, chi is the letter x. X squared, chi-square. Okay. Other statistical analyses for non-parametric values, okay, like the ANOVA and all, we have the Kruskal-Wallis, but there's also, if you have one group on multiple things, there's a test that can be used called the Friedman's test for repeated measures. It's one group, multiple things you're measuring. It could be the Friedman test for repeated measures can be used. Values, t-tests, t-value. We would think the ANOVA would have an A value, but it's not. It's an F value. Mann-Whitney U test, it's a U value. Chi-square, chi square. So it's chi with a little 2 next to it, squared value. Correlations, relationship, R value. In terms of what's important, statistically, what we want is to find the probability that the null hypothesis is valid. So we use a P for probability. Okay, if we get a p-value equal or less than 0.05, does everyone see that? Now, if you're good at math, 100% minus 0.05 would be 95%. Okay, because that's 5%. Okay, the thing is, what we're saying is, if there is a significant finding that's 95% or less, well, less means more. 0.02 would be 98%. 0.01 would be 99%. Okay, just to give you some numbers. Okay, so we would love to have p-values equal to, especially less than 0.05. That is a significant difference. And we definitely would reject the null hypothesis and say there is a difference. How do we know which difference? look at the mean values for the two groups. If we're looking at errors, the lower mean value, the lower errors. If we're looking at number or percent correct, the higher the value, right? Okay. Okay. One more statistical value is degrees of freedom. Okay. There may be questions about this, but this is how it's done, how it's figured out. You take the number of subjects in your study. If you have two groups of 10 subjects each, that's 20 subjects. If you have two groups of 5 subjects each, that's 10 subjects. You got it? If you have one group of 20 subjects, it's 20. If you have one group with 6 subjects, it's only 6. If you have 3 groups with 5 each, it's 15. So please remember that, okay? Okay? So we have 20 subjects. Then what are you measuring? Pre versus post. Pre-therapy, post-therapy. That's 2 factors. So we have the number of subjects, the number of factors. And the way we do it is we take the number of subjects, the total number, the number of comparisons, which in this example is 2, and the degrees of freedom equal 20 minus 2. You got that? Okay. If it's one group, instead of 20, it's 10, it'll be 10 minus 2. Okay? Which will be 8 degrees of freedom. And from a significance factor and all, degrees of freedom or not, it's the R value and all, the P value. What's the P? If that P is equal to or less than 0.05, it's significant. If it's greater than 0.05, like even 0.06, oops, it's not equal or less than 0.05, it's not significant. They're not, you have to say the null hypothesis is valid. There was no significant difference. No difference. There was no significant difference. Values and correlations. Okay. Thus, if relationship of 0.8 would be an 80% relationship, right? Well, that's what we want. We typically would love to have, when there's correlations, at least an 80% relationship. But even though they're not significant, we can say, so what does it look like? Okay. A weak relationship is 0.29 or less. So if you get, the R value 0.28, 27, 29 or less, it's very weak. And I think you would agree, if it's weak, there's not a significant difference. Okay. Moderate, 0.3 to 0.49. Okay. It's a moderate degree. That's the R value. If R is 0.5 or higher, it is strong, but the best we have is at least 0.8 or higher, and the ideal best would be 1 or 0. 1 is 100%. 100% significant relationship. Or 0, there's absolutely no relationship. That 100% supports the null hypothesis. Evaluating evidence. Look at that p-value. Okay? If p is less than or equal to 0.05, we reject the null hypothesis. There is a significant difference. Look at the mean values for each group. The mean value that's in the way you want to go, better or worse, depending on where you're looking. That's the group that did significantly better or that had significantly fewer errors. Okay. Variables, 2 categories. Independent, the word is in. These are the things you choose going into the research. Questions can come up. What are they? If we have 2 groups made up of 5 boys each, or even better, okay, yeah, 5 boys each. They all are 8 years of age. I'm trying to think what else. They all had normal IQs. They all had whatever we're working on. We'll say articulation. articulation disorders based on Goldman-Fristow testing, would you agree we've gone in with a lot of good variables? They are what we have chosen to go into the study with. Then we test something. The results of our test depend on whatever variable we're measuring, the number of hours of therapy, the type of therapy used. Let's see, whether they're doing, home therapy, we're giving them homework, whether they're doing the home practice or not, whatever it is that we're using, the materials we're using, those dependent factor, significant differences or not significant differences, no hypothesis, depend on the analysis, the statistical analysis we did. With descriptive research, we still have independent variables. What we're choosing, who we give the things, or who we ask the questions about, or the things we're observing. Okay? We can observe behaviors, and that's just describing things. Okay? And the dependent variable is, let us say we're describing behaviors, and we notice that the kids who are doing the best with their therapy are kids who are behaving this way. They're sitting, even if they're moving around while they're sitting, right? If you can see me moving around while I'm sitting, okay, they come on time. I didn't measure that or use that as an independent variable. You have to be there at a certain time, but maybe you could be a little late. You still get the therapy. Okay. And so that we could use things that depend on, descriptively, how did they do if they came a little late and all of those kinds of things. Okay. And in our descriptive research, we use triangulation. That's where we look at least three things that tell us one important thing, such as the report from three different people. Okay. Does the child seem to have an attention problem? Okay, well, let's see. I ask him a question. The first thing he does is, I'm sorry, what? Okay. Next thing is I'm giving directions, and the child doesn't do the directions. I ask the child, what did I ask you to do? The child says, you asked me to do something? That's two. And let's say there's a third behavior that I observe, not measure, but observe. It's qualitative, right? And it is what? Descriptive. So those three things, and this is the best way to say it, make it appear that perhaps the child isn't paying attention. Now we want qualitative stuff, really good qualitative stuff. That is, we need formal testing to find out, does the child truly have an attention disorder like ADHD? Okay. Using research for evidence-based practice, I think it's kind of straightforward from what I've been describing here, right? Okay. The problem no longer exists. The child has reached the 80% level or whatever it is. And the thing is that we can use our research. And when we do therapy, think of it as research. Keep good records. Okay. Okay. So using research findings from the literature, using our clinical findings provides evidence-based practice. If our clinic observations descriptively say, these people are not doing well, I'm only seeing them once a month, I'm only seeing them once a week. Okay, maybe you do need to see them more often. You have a comparison that you're describing because you're not doing, independent variable factors. You're just choosing what you've observed. And the thing is, you might say, something, the group that comes more often does better at situation, at, let's say, facility A, I'm moving around to different facilities, facility B, facility C, and facility D, there's no difference. But there's three out of the groups that show the difference. Maybe, the more often you give therapy, the better you would expect the outcomes. Special research. There's other types of research. And one of them is called meta-analysis. if it comes up on the praxis exam. The question would be, is somebody reviewed 20 previous research studies and found the following. I have done a meta-analysis. Basically, I didn't do the research in terms of the actual experiments, but I looked at research articles with an occupational therapist. I can't remember how many we looked at, but I will take a wild, wild guess that the number that we looked at probably was somewhere around 20. And what we did is we found patterns, very descriptive research, patterns of the research. So we analyzed previous research, describing it. Okay, let's see what these 20 research studies indicate regarding the outcomes for treatment A on clients, patients, students, whatever it is, with the XYZ disorder. And if the 20 studies show a lot of things, that's research that people might want to look at. It's not just this article, that article, that article. Your article looked at all of them, all 20 of them. Interpreting, consider the number of participants. We want at least sample sizes of 25 subjects per group. In a group, if one group, it's only 25. Two groups, 25 each. Okay, we'd love to see 100 subjects or more. If you see less than, let's say, 20 subjects, right, it's still okay. Or less than 25 subjects, rather, it's still okay. It's called pilot research. I've just done a pilot research study on 16 subjects. Okay, but I say it's a pilot study. What's the next thing you need? Let's do it on more subjects. Let's add to these 6. Okay, also describe whether there's quasi-experimental or true experimental. Did you really control for all the variables you're able to control for? Could there be variables you're not able to control for? The other thing is, what were the inclusion and exclusion factors? Meaning there were subjects that were put into the study, but then there were subjects who could be in the study, but they were excluded because of certain factors. Excuse me. Generalizability. Is the sample size large enough? If you're only doing, let's say, 5 or 10 subjects, it's not generalizable. It's too small. Okay. The other thing is you have 100 subjects. What age? What were the ages? Say there were 10 age groups, 10 subjects each. So it is 100 subjects for the group, but there are 10. So you may be able to do the group data, and that could be very, very, very reliable and very generalizable to, your work as a speech language pathologist, other people's work. But if there's only 10 groups of 10 people by age, right? I hope you would agree that you can't say for each specific age that it's also generalizable. Replicability, okay? Is there anything in the study that show, for example, if I do therapy twice a week and I'm doing the same thing twice, both times, and I'm seeing the same kinds of, improvements, even though maybe a little more, the second time than the first time, I'm repeating what I'm doing. But if I'm doing therapy A, then the next week therapy B, then the next week therapy C, then the next week, where's the repeatability? How do I know what actually made the improvement? Validity. Does the study truly measure what it measures? Are the outcomes truly identified? Here's an example. A study of 20 subjects, but I have no idea if they understood what I was doing with them in therapy. So is there lack of progress because the therapy treatment did not work, or because I did not appropriately explain it? They did not appropriately understand what to do. That's important. Like I said, what about the subjects with 130, 140 IQ versus the ones with an 85 IQ? Okay, so it may be valid for each individual group, but how do you compare them if you don't think about the IQ stuff? Reliability, can the results be replicated? Okay, internally within the study or between two different factors or whatever factors that were evaluated. Validity, reliability, does the test truly measure what it claims to measure? Does these Goldman-Frislow test of articulation evaluate a subject's language. Here's the best of all, because this I see very often in does only evaluating expressive vocabulary and receptive vocabulary evaluate a subject's language abilities. I have to hope you agree with me. The answer is no. It only evaluates their expressive and receptive language, but it doesn't look at other factors like their ability to put words together in a sentence to get the main idea of something, right? To analyze, the main idea of something. What else? You understand the grammar, okay, within a sentence. Good example of that, and some other things too. How much is 2 plus 1? 3. Versus what is the difference between 2 items and 1 item? I hope you agree. The answer is not 3 anymore. They mean very different things. So try to remember the way it's stated. Okay, validity internal within the study. That's internal validity. External, can it be generalized? We used a sample of children 6 years of age. Conclusion, this therapy is appropriate for elementary school children. I'm sorry, you used only 6-year-olds. I hope you'd say that internally it was fine with those and it was truly valid with those subjects, but externally, it doesn't tell me anything about younger children like preschoolers, 3-year-old, 4-year-olds, kindergartners, 5-year-olds, 6-year-olds. Maybe this 6-year-old is just at kindergarten, first grade level, so we'll say that's okay. But what about the 10-year-olds? What about the 12-year-olds? Research finds A treatment is perfect for XYZ disorder on children 10 to 18 years of age. But here's this question. Is it valid below 12, 10, and above 18? The answer is we don't have data to support that. Researcher bias. What is that? Real quick. Okay. Researchers very often can be biased. I just developed the XYZ test. Well, before you even finish the research, would you agree with me that I'm probably biased that I want the XYZ test to be better than the standard test, so you'll buy it, right? Because it's my test, okay? So if the researcher says, I have developed this test and I'm testing it out, regardless of what he says, I think it's the best test made, the best thing is to say, I'll look at it more objectively than you looked at it subjectively. The best researcher would say, I developed this test and the results show that students who, use this test perform better than this, or I found better results with the new test than with this, right? At the end of a research study, they very often put in future research, what's needed. And maybe the person to unbias their bias is future research needs other professionals using the new test to determine, as we found, or as I found in this study, that it was better than the standard test that's used. Yeah, other professionals, right? Then it's not me because I'm not biased. And I'm not going to work with the other professionals. Just read my research. Summary. There are many, many factors that need to be understood for research concepts. And then the main factor with evidence-based is, does the research support, is there evidence to support the use of this in our professional work as speech language pathologists? There's a small percent of questions on the practice exam that ask specific questions. They may present, an example of research study and ask you, is this descriptive? Is it experimental? Is it correlational? Read what we talked about, review what we talked about to remember what each is type. Okay. Are the results significant? See if there's a p-value, and is it equal to or less than what? 0.05. Right? Okay. Know these general concepts for evidence-based practice. Thank you all. If you have questions, and if it's allowed, Here's my email address. Here's my phone number. I'm happy to answer any questions, but we are finished. And so if there are some questions, I'll be happy to stay for another 5 minutes if anyone wants. Otherwise, you can contact me later. So thank you very much.